Sorry, people say can't see it there. What you're doing. The camera. Sorry, I will go back. Long enough? Okay. So what I'm doing actually is I'm making this connection. So, sorry, first with the long wire and now with the breaker. Okay. Sure. Yeah, but then you can't see the screen. So. Okay, but you see what you do. So actually it's the connection here, so it's the sheathing is taken off here. So this and on top. So here's the sheathing taken off. It's loose. Now I'm making a connection to my back sliding panel with this. So then what you get is actually okay. So if you look at current now, it's 8.7 amps peak to peak, and then I make the connection. Now it's going to, let's say, 250 milliamps. Wow. So there's a much bigger difference. And of course, it's better if you blend. So the 360 degrees differential connection. So this is simple installation practice for industrial installation, but also in your car. So you've got to do the same.
It's shielded both sides.
Always both sides. So in order to make lens law work, you have to connect here with a low impedance down here and use a good quality cable. So you've got very quality cable. You have to use a dense braiding, actually maybe a foil inside.
Yeah.
Well, not to the earth bit or something. You don't have in the car because it's the metal work of the motor and the drive.
It's a return for the common mode, actually. You wanted the noise to go through there.
But doesn't that increase the crosstalk on the wire you have the braiding wrap?
It increases the current in the screen, but that's good because it's close to the.
But that doesn't that create crosstalk on the signal you're actually transferring from the motor to the controller? Because it protects the rest, but it doesn't actually.
If I've got your, let's say, a temperature sensor in the motor, going back to the power electronics or maybe to a PLC or any controller, then you would see the same reduction because. Well, let's do the exercise. I've got my current loop signal here. So I've got a sensitive cable. And I'm going to measure here. I'm going to switch on. So this is actually the noise going to my sensor cable. It's some 800 milliamps. But again, if I keep the disturbance inside the disturbing cable, like this.
Yeah, but if you were not to break the sensor cable and attach both ends, attach the braids on both ends, wouldn't that?
Would even be better.
Yeah.
Yeah, because if you because what happens then is, if this would be the sensor cable, then you would have some noise being picked up by the screen. But it's actually going on the screen, so when you connect it here, then it's going off, it's not going inside. So if you do the measurement here and here, you will actually see this go up if you connect screen on both ends for the instrument cable. And see this one go down because current tends to go out back to the source.
What you probably mean is that when you have a microphone, you connect the screen on both ends, it will hum. You will get a noise. That's resistance.
That's 50
I
hertz.
times R. There's a current times the resistance of the braid will create a voltage over the braid. And if that voltage is much bigger than the signal of millivolt, microvolts, then it will dominate. So I times R is a problem. So low frequency is difficult to shield. High frequency is easy to shield. And this is an inductive effect. And the resistive effect, if you have a very tiny signal and you have a shield on it, you have to be careful. What they sometimes do, they take the tiny signal on 2 wires inside the screen, and then the screen is outside, and the 2 wires together will compensate.
But it makes sense that for low frequency to put a solid earth conductor here as well.
Yeah.
Because if you put a 50 square millimeter earth wire, then there's nothing going in your instrument. Low frequency.
Or 50 kilowatts lightning would you like to have outside your cable?
Yeah, it is. So it's a mixed solution, low frequency, high frequency. Well, we promised not to do any number crunching, but
Just one for the exam. Just one for the exam.
this is for the examination. So Fourier, if you've got a square wave, you can write it in an array of carrier frequency and harmonics. But what happens that if you've got a frequency envelope here, then this corner frequency here is actually determined by the rise time. So again, in all the exercises, it's the steepness of the voltage and the current. So the time transition that actually gives you the size of the frequency wave. So make things as slow as you can. And you can actually calculate it like this. So it's really in the megahertz range. So with my spectrum analyzer, I can go through the source waveforms and see that actually at 20, 30 megahertz it stops the noise here. It has to do with the type of transistor that is being used for the drive. So also for your automotive motor, I think you need a motor with high quality winding because of voltage spikes. It's not EMC, but to keep the thing alive. You need a good quality multi cable. Shielding quality, of course, low impedance, low transfer impedance. And especially low impedance terminations. So preferably use glands rather than pigtails. And also for the control cabling, of course, because it's equally important to shield your sensitives. And I think without filters, you're out of business. You need some filtering to keep your battery voltage clean for the other circuits. So to get rid of the noise on the power supply. Well, here are some typical requirements from the vendors. Actually, you buy a device nowadays and you connect it to the motor, but you have to read the manual where it tells you everything about EMC. So here's where the mechanical stuff is. It's a mechanical problem to connect the screens. There's clamps or glands or
is it possible you can go to the previous sheet? See you have say to watch out on the installation of the motor. What would you suggest for to a good installation type, but also to keep the motor cool?
Well, the installation is about the insulation of the wiring inside. So it's actually a very thin layer, and that is required because all these spikes